Okay, so I'm Tobias Ternstrom, or Tobias Ternstrom, and I'm going to talk to you a bit more about the programmability features that we've added to SQL Server 2012. Now, the first thing we're going to look at is the new language capabilities. And then we're going to dig into a few of the scalar functions that we added, and then we're going to call it a day. So first, what we did is the language capabilities, adding something for generating unique values across a number of tables or even across different servers is something that many people have been trying to do for a long time. Now, we have GUIDs since SQL Server 7, and we also have identity. The problem with GUIDs is that it's not right for all environments, especially if you want ever-increasing values and you want to use a smaller type. Identity is tied to a single table. So what we did here is add support for that ANSI standard sequence generators. So you can create, alter, drop sequences, and then you use them using the next value for function. And you can also retrieve ranges using the SP sequence get range store procedure. And this is a really powerful capability built into the server that also helps migration between platforms. So I'll go ahead and create the sequence S1, and I'll go ahead and call it using this next value for function that we saw on the slide. And as you can see, it returns the lowest bounds of the type, and by default we get a big int type. And this is just so that we make use of the full range of the full domain of the type that you selected. If I go ahead and just drop my sequence and recreate it, and by the way, you can alter a sequence. The only thing you can't actually alter is the type. So I'll go ahead and say as integer and start with 1 instead. And now when we call it, we can see that it starts at 1, 2, 3, and so forth. Now I can also go ahead and do a bit more complex query, or simple, but at least simpler than, or it has at least a from clause. So sales.customer, and now we can see that it keeps generating unique values. And by the way, this is you can run concurrent queries. We don't actually block on the next value 4 within a transaction. So you will, for sure, if you run this in high performance environment, you'll get gaps in these next value 4. You'll get one query get 1, 2, 3, and the second query gets 3, 4, 5, or 4, 5, 6, and then the first query gets the next, and so on. Okay, then I can also use the sequence in a table default constraints. So if I create here sales.t1, I have my ID field, and the default is basically next value for S1. And I can use it in T2 as well. So now I know that the IDs generated across these two tables are actually unique, and there will be no blocking in between them. You can also generate a range using the SP sequence get range store procedure, which is good for offline or remote environments where you want to get, for example, 1,000 values and then prepare a file that you're planning to load, or get 1,000,000 values and assign it to a sequence on another server, so you know that that server doesn't generate values that actually conflict with your local server. So after looking at the sequences and how you actually use them, let's take a look at the query paging functionality. So this is really something simple for you to make your guys' life easier. It's a very common thing, especially in web environments, to just ask for the first page, second page, and so on. So it will allow you to now say offset the first X rows and then fetch the next X rows. And let's take a look at the demo of this. Okay, so the other thing I wanted to show is that we are now supporting the much easier paging scenario using this offset and fetch next clauses that are defined by the ANSI SQL standard. So again, we'll do a simple query against the customer table. And now let's say I would like to just fetch the first row, second row, and so on. And obviously you can have inner joins or joins of any sort, group by, etc., for XML, all of these things. I'll just do this simple query. And now I want to get the first rows. So I'll say, hey, skip the first 0 rows, since I don't actually want to skip anything, and then fetch next 10 rows only. Now this will fail just because I'm required to provide an order by clause so that it actually makes sense. Note that if you want this to actually be somewhat stable of a result set, you should include a unique column for your query in the order by clause. Otherwise, depending on the plan we pick, you may not actually get the second page, right? You'll get the second page of whatever plan we picked. So I'll say, okay, order by, let's see what columns we have. Okay, I'll say order by account number, which presumably is unique, but I'll also go ahead and add the customer ID, which is the primary key of the table. And now we're fetching the first 10 rows, and then I say, okay, skip the first 10 and fetch the next 10, and so on. And obviously you can use a variable or an expression there as well. So I could say, hey, offset 10 times 10 rows, so that's 100 obviously, and then we'll do that. So we support expressions, variables, you can even write a subquery in there. But it's a simple way to do paging in SQL Server 2000. Now that we looked at offset and fetch next, we also have added support for simpler error handling with the throw statement. So you can use throw to throw an error, which will abort whatever your scope you're in. And if you're in a try block, we'll move you to the catch block, just like regular or many other languages. And in the catch block, we also support you saying throw without any arguments, and we'll just rethrow the current error, which is something that many customers have been asking for. Okay. Now the other thing we did was we invested a lot of time in making sure that we extend the support for the over clause, and what is often referred to as window functions, and adding more analytical functions. This is great capability for both solving simple use cases, which are actually hard to write in regular SQL. It's also something where you can handle very advanced queries, such as give me the average stock price over the last 5 minutes, for example, or a rolling average. Let's take a look at an example of how you can do this. Okay, so let's just have a look at the canonical example of I want to actually figure out what the balance of an account is over time, so a cumulative total. As I mentioned, this is not impossible to write in previous versions of SQL Server, but if you want to get performance, it's definitely a challenge. So in SQL Server 2012, we spent a lot of time making sure that we support a great deal of the ANSI standard here, and this makes your life a whole lot easier. And if you spend some time on learning new features, this is where you should spend extra amount of time, because this is one of these things, once you get in the Zen mode of it, you'll really love it. So I'll just I will use the orders table here just to make to create the query. So select from sales order header, which is the actual order, and then I'll just join with the order details. So we're joining on the sales order ID column. And I want this sorted by just the order date and the order ID to make this unique. And also the order detail ID. So we'll pretend that the order detail table is actually a transactions table for a banking system. Okay, so we're running this query, and it fetches all of the values for us. What I would like to do now is pick the, let's just take a subtotal column and just make this into a cumulative total. So let's just say we will show just the sales order ID. We'll just basically show these columns. And then I want the transaction value for this row, which then is the subtotal column. Or maybe it's not. Let's just use unit price. Okay, and now I want to actually add this cumulative total. What I can do now is I can say, hey, give me the sum of unit price. If you try to execute this, you'll get an error saying, hey, this is not actually a grouping. You'd have to add a group by clause. what we did in SQL Server 2005 is that we added the over clause, right? And so I can say, give me the sum over the complete window, which is the full set. Now you see that I get the full value across all of these. So that's the total balance, or the full balance of the account at the end, right? The sum of all of these transactions. What I can do now is I can say, hey, also give me this order by basically these columns, right? And what this implicitly does, according to the standard, is it gives me a frame where it gives me from the first row until the current row. And now, as you can see, I have a balance here. So from 5 roughly to 10 to 45 and so on. And you write this query as simple as that. And like I mentioned, this by default, the order by includes the between rows, in this case, between what is it? Unbounded preceding and current row. So this is what this actually translates to. It actually translates to range, but in this case it's no difference. So now we just wrote a query very easily that performs very well and does something that was very complex before. And as I mentioned, you can go to great depth in this over clause with all of the functionality we added, lag, lead, and so on. So just, if you take some time with anything, just immerse yourself in this and you'll really see the power of SQL. Cool, okay, so the final thing I wanted to show you guys is that we also added a lot of just interesting, simple functions to the T-SQL language. And a couple of these are try convert and try cast, which is basically try to cast into a certain type, and if it fails, just return null. This means that you can do many things where you would require something like an isNumeric, isDate kind of function, with being able to specify this is the actual type I'm after. It's also great for data integration scenarios where you're loading strings and you want to cast them to specific types. We added the format function, which allows you to just convert types like dates or numbers into specific formats using .NET functionality that's available. Basically, the toString method on these types in .NET, where you can say, okay, convert this to this specific picture string, or convert this to this specific format in this specific culture. Parse and try parse is really the reverse of that. So parse is take this string in this certain culture and convert it to this type. And try parse is analog to try convert, try cast, where okay, if the parse fails, then return null. We also added functions that many people have been asking for, just if, choose, concat, which basically does what you expect them to do from if you've been using other Microsoft products like Excel or Access. And finally, we also added a few basically constructor functions for our date types. So it's very common for you to want to generate static dates. So you can say, hey, give me date time from string, and then we'll basically take a bunch of integers in. You can specify this is exact date or date time or small date time or date time offset or whatever function you want to, or type you want to generate. Also the end of month function, or EO month, that gives you the last date in, or the last day in that particular month. We also looked into the EO month or EO time function. Turns out that was more complex to do because we don't really know when the end of time is coming. Cool. So let's have a look at a few examples, and thanks for watching. Okay, so let me just show you the benefits of two of these functions. So like I mentioned, try cast, try convert really makes life easier if you want to figure out if something is convertible to a certain type. And it really works like if you use the functionality in .NET Framework. So let's just say I want to fetch all values from the sales.sales order detail table. Now let's do the production.product table. Okay, so let's say that we want to try a conversion, get all of the values where the product number is actually convertible to an integer. So while I can say, okay, try cast name as integer, and you'll notice that we return null, I'm guessing for all of the values, because they're obviously not convertible to an integer. And this you can obviously use in a case statement, something like this. Hey, case when this is actually not null, then we'll go ahead and do something. In this case, though, you can also use it as an isNumeric, isDate kind of function, which is guaranteeing you that if it succeeds, that cast actually succeeds. So I'll say, okay, where try cast, this is not null. Now I'm guaranteed to get all of the rows where this is actually convertible to an integer. Let's go ahead and look at another function, which is the format function. So this is one of these long-standing asks. It's a simple function, but it makes your life so much easier. So let's just take the order date column here from the sales order header table. So what we return here is whatever type we have stored, right? So a date, date time, or something like this. And it's up to the client to decide what format it renders it in the string for me. So depending on my original settings here, now I'm running Swedish settings, which uses the ISO standard, so it's actually legible for human being. It's year, month, day, not like these month, day, year that they do in some other countries. At any rate, now let's say I want to actually control this because I want to generate, for example, an order number or something based on the date. So I can say now format this date column using a certain format. So I'll say, okay, I want to have year, month, day. And we actually leverage the .NET framework here. So whatever picture strings, so one of these guys is called a picture string, works in .NET will work here. And as you can see now we get year, month, day without anything in between, and we don't get the time. And obviously I could do something like 2 underscores here, 2 underscores here, and that's the date we'll get. We can also say, hey, I want to get long date format, and now I'm getting, because I'm running on an English language, I'll get, okay, July and Friday. I can also say, hey, I would like to get this in Swedish culture, and then we can see it's den 1 juli 2005. So this is very simple but very nice functionality, and it's built straight into the product.